Hello students. So in my previous lectures I was discussing a type of optical detector, that is photovoltaic cell, and there in the previous lectures I discussed about what is photovoltaic cell, what are the prerequisites for the understanding of the photovoltaic cell. I discussed all the prerequisites and I discussed about the construction and working principle of photovoltaic cell. So in this lecture also I'll be continuing with the same topic. I'll discuss here the VI characteristics of photovoltaic cell. So you can see here the VI characteristics of photovoltaic cell in this slide. This graph shows the current voltage. This is the current voltage. This graph shows the current voltage characteristics of a typical silicon photovoltaic cell operating under normal conditions. So with the solar cell open circuited, that is not connected to any load, that is when there is no, like in this picture, when there is no load here, when there is no wire connected to this photovoltaic cell, so we can say the solar cell is open circuited. So with the solar cell open circuited, that is not connected to any load, the current will be at its minimum and the voltage across the cell is at its maximum, means this point. Obviously there is no wire connected to the photovoltaic cell or there is no closed circuit, so current won't be able to flow. So the voltage across the photovoltaic cell is the open circuit voltage and it will be maximum and the current is minimum, or you can say the current is 0. So we can say that the solar cell, this maximum voltage, so this maximum voltage is the solar cell open circuit voltage, or you can say VOC, we designate it as VOC. At the other extreme, when the solar cell is short circuited, means a wire or a load is connected across, or you can say the solar cell is short circuited, wire is connected across the P and N type of the solar cell, that is the positive and negative leads connected together. The voltage across the cell is at its minimum, that is 0, but the current flowing out of the cell reaches its maximum, known as the solar cell short circuit current, or ISC. Then the span of solar cell IV characteristic curve ranges from short circuit current at 0 output voltage to 0 current at full open circuit voltage. In other words, the maximum voltage available from a cell is at open circuit and the maximum current at closed circuit is available. The maximum current is available at closed circuit of the photovoltaic cell. Now, since the power delivered by a solar cell is the product of current and voltage, of course, neither of these two conditions, like the which two conditions I am talking about, the maximum voltage that is available from a cell, that is when the cell is open circuit, this is the first condition, and the second condition, maximum current which is available from the photovoltaic cell when it is at closed circuit. So neither of these two conditions generate any electrical power, because in both the situations you can see either the voltage is 0 or the current is 0. So for finding the power we need both voltage and current. So none of the situations is going to generate any electrical power, but there must be a point somewhere in between where the solar cell should generate maximum power. So however, there is one particular combination of current and voltage for which the power reaches its maximum value at IMP and VMP. This is Imax, or you can say Vmax, at these 2 points, when these 2 points collide. So this is the point on the graph where the power will be the maximum. So there is one particular combination of current and voltage for which the power reaches its maximum value. In other words, the point at which cell generates maximum electrical power, and this is at the top right area of this rectangle. So this is the maximum power point. Therefore, the ideal operation of a photovoltaic cell is defined to be at the maximum power point. So why are we so concerned with the maximum power point? What is the purpose of photovoltaic cell? Photovoltaic cell converts light energy into electrical energy. Means it is inducing voltage, it is converting the light energy into the voltage, or you can say into the electrical energy. So the purpose of photovoltaic cell is that it should give maximum electrical power. And maximum electrical power, this is the graph of photovoltaic cell. From this graph of photovoltaic cell we can see this is the maximum current a photovoltaic cell can give when it is short circuited, and this is the maximum voltage a photovoltaic cell can give when it is open circuited. But at both these 2 points power will be zero, because at this point voltage is zero, which will make P is equal to VI is equal to 0, and at this point current is 0, which will again make the power to be 0. So we need maximum power, we need the ideal operation of photovoltaic cell where the power is maximum, electrical power is maximum. So it is at this point where the current and where the combination of current and voltage is such a way that it will on their multiplication it will give the maximum power. So this was about the VI characteristic of photovoltaic cell. Next I am going to discuss about the output characteristic of photovoltaic cell. So this figure represents the output voltage characteristic of a solar cell. So here x-axis represents the intensity of incident light and y-axis shows the output voltage produced. As can be seen that with the increase in the intensity of light there is an increase in output voltage produced. Why? The reason behind it is I have already discussed in the working principle of photovoltaic cell. So this was about the voltage. So with the increase in intensity of light, voltage will increase. Similarly, moving further, let's have a look at the output current characteristic of a solar cell with different load resistances. Which load resistances I'm talking about? As you can see in this diagram, this load resistance. So with different load resistances, I'll be showing you the graph of current with respect to intensity of light. So here also with the increase in the intensity of light, the resultant current through the cell also increases. The output current is low and its value lies in microamperes. You can see the unit of the current is in microamperes. So the output current is low and its value lies in microamperes. The achieved output current relies on the intensity of incident radiation, the size of the cell structure, and the conversion efficiency of the device. So these are the three things on which the achieved output current relies. Again I am repeating, it relies on intensity of incident radiation, size of cell structure, and conversion efficiency of the device. The output voltage and current obtained from the single unit of a cell. Now as you can see, this whole discussion was about the single unit of a cell. Now the output voltage and current obtained from the single unit of a cell is very less. The different combinations of cells are used for increasing the output efficiency. So there are three possible ways of combining the photovoltaic cells. So I'll be discussing about these combinations in my next lecture. I'm ending this class here. Thank you.